Hello everyone. Today we are taking you on a journey to a human-augmented autonomous SOC, where AI handles the heavy lifting and analysts stay firmly in control. Most SOC teams are overwhelmed by alert volume and noise, spending too much time sorting signal instead of really stopping real threats. Stellar Cyber changed that by combining full-stack visibility with multi-layer AI, so decisions are made earlier, faster, and with confidence. Our agentic AI doesn't guess, it runs structured checks, build context, and make verdict before an analyst ever gets involved. Analysts remain accountable with the ability to review, override, and continuously improve the system through feedback. We will start with a 5-minute demo, then deep dive into 5 key workflows: detection management, threat intelligence, threat hunting, response automation, and dashboard and reporting. So let's get started. So this is the Stellar Cyber SOC overview. One place to see cases, alerts, and user, all in the same UI. The kill chain view shows where attacks are progressing from initial attempt to exfiltration, so analysts know where to focus immediately. From this screen alone, you can tell what's matter now, what's getting worse, and where human attention is required. So before we dive in, it's important to note that Stellar Cyber is multi-tenant by default, by design. Everything you are about to see, case, alerts, dashboard, and even detection configuration can be viewed for a specific tenant or globally for all your tenants in your organization, all from this one single console. This is what allows our MSSPs and large enterprise to scale operation without duplicating efforts. So let's start right in the case management dashboard. The cases that you see here are already correlated, already analyzed by the multi-layer AI. They come with a verdict, true positive, false positive, or sometimes inconclusive when the AI has not been able to come up with a determination verdict. So let's look at a specific case, compromised credential data theft. So before an analyst even look at the case, the AI already did the heavy lifting, right? Come up with an overview of the activity that has been observed, the key insight, the impact, and some recommended next steps. So in the Analysis tab, we see the observable, the list of different artifacts that has been extracted from alerts that compose the case, including user email, user ID, source IP, etc., as well as their relationships, how they collaborate, how they interact with each other. The timeline overview is providing a summary of all the different alerts and sequence of alerts that are combining and creating that case. And the hypothesis provides some educated guess of what the AI believes is happening. The response tab provides a very detailed set of recommendations of what should be done for that specific case. And we will deep dive into this section later on in the demo. So with Stellar Cyber, as we said earlier, we can reduce noise drastically, remove false positive and irrelevant alerts for your organization. So let's look at an example. This suspicious creation of email forwarding rules in Office 365 has been determined as false positive. Let's understand how the AI is determining that specific verdict. So we can see that this case is a combination, a correlation of multiple alerts, and that each of them has a false positive verdict. So in this case, that is composed of 9 individual alerts, mixing phishing, email collection, and suspicion of exfiltration. The AI analyzes each of them, correlates them together in this specific case, and come up with this false positive verdict. Let's look at one of this alert on what type of information or the type of analysis that the AI is providing in order to come up with that verdict. We can see here that the AI is looking at the past behavior, right, of that specific user. It has 4 similar alerts in the past 7 days with that are aligned with known benign testing activity. There is no phishing-related alerts or unusual email pattern were detected, and this device is compliant with the baseline and compliant with the organization. So most likely that supports the conclusion of a false positive. This is not really a threat or malicious activities. So that's the AI summary for this alert, and there is a detailed analysis of every single checks, every single steps that has been done to come up with that false positive verdict. Now let's look at a case that needs to be reviewed by human analyst, a case that has been determined as true positive. So we are going to go back to that compromised credential data theft case. So in this case, there is 11 alerts, and that has been again correlated together. Let's look at this impossible travel anomaly alerts. So here, again, the AI is doing a set of checks, those verdict signal checks that help to justify or explain the verdict. So we can see that there is 47 logging attempts out of 60 total attempts, which is a very high failure ratio. This attempt are originating from 5 unique source IPs, and the analysis revealed as well that there is 12 similar alerts over the past weeks, including 3 of the same types for the current alerts. So all those different signals indicate that this is most likely a coordinated attack sequence. The presence of this IP from Berlin, from this unusual location, was not part of the user historical logging pattern. So that further support the hypothesis of this is an ongoing malicious activity. So just an example to see how the AI is combining multiple signals, multiple data points to come up with that verdict. Now, as an analyst, I may have a different opinion. I may have the context that the AI don't have. So I can provide that feedback to the AI. I can override the verdict. I can say, yep, this alert is a false positive. I'm going to I validate with the end user. This is a legitimate travel. This is a false positive alert. So this is a way for the human analyst to provide some feedback to the AI in order to provide this additional context and make sure that the AI will understand that behavior and will remember that for the next occurrence of a similar alert. This is what we call human-augmented autonomous SOC, when the human is on the loop, can provide some additional context, additional feedback to help the AI to improve over time. So we will start right away in the case management dashboard. So as I said earlier, this view is multi-tenancy. So you can look at for all tenants, look at for a specific tenant. That's what helps our MSSP partner to tailor the view to exactly what they want to see. So in some situation, the AI doesn't have all the context required to come up with a verdict. So that's why we have this inconclusive verdict, where the human is required in order to come up with a better qualification of the severity of the case. So let's look at a specific case, compromised credential data theft, that has been determined as true positive. So what we see here first is the case summary. That's a pre-generated summary that combined all the information that as a human analyst you need to know. The overview, what's going on, the key insight, the different sequence, different events that has been observed, the impact of those events, and the recommended next steps. So all in one single block of text that you can copy and paste to your tickets or your own documentation system to document the case. In the Analysis tab, we see more details. We see the graph, what are the different entities and how they interact with each other, a user, a laptop, some files, for example, as well as the summary of those relationships. Right? On the left panel, we see the relationships, user ID, user email, source IP, etc., with all the detailed information that has been extracted from the alert and the relationships between those different entities. In the Hypothesis tab, we see a detailed explanation of what has been observed. That's the AI judgment or educated guess of what are the behavior that has been observed in this specific case. The timeline overview is giving us a summary of all the sequence of events in this specific case, which is very useful to understand the different interaction, different sequence and milestone in that specific attack path that has been observed. In the Response tab, we see the detailed recommended action. For example, this account needs to be logged down, and the AI is providing all the different information that you need to know, which is the account name, what are the different IP address if you decide to investigate further specific IP address or even to block that IP address. You have all the information that you need into this one single panel. Let's go back to the detection tab, and we see the details alerts that are composing this case. In this situation, there is 11 alerts. They all come up with a verdict. Again, true positive, false positive. As an analyst, I can deep dive into each single alert and understand the reasoning behind the verdict. For example, this user logging location anomaly here is, again, determined as a true positive, and the AI is explaining why this is a true positive. In this specific example, we have 47 failed login attempts out of 53 total attempts, which is a high ratio of failure. We know that this is an unusual location, and we know as well that the login is originating from a new non-compliance device and exhibiting an automating browsing pattern. So there is 2 new inbox rules that were added, including external forwarding, which is directed to an unknown domain. All of those observations are strong signal for a true positive verdict that reinforce the suspicion of a compromised account. So in addition to the AI summary for the alert, we have a detailed AI findings that describe all the different checks that has been done to come up with that verdict, as well as the result of that specific check. Now let's look at an example of how Stellar Cyber helps to reduce the noise. A case, for example, where the AI come up with a false positive verdict, where the AI is considering that based on the situation, there is no risk and no malicious activity. So we are looking at this specific suspicious creation of email forwarding rules in Office 365 case. We see that all those alerts are false positive, and if we look at the detail, we understand why we have such a verdict. So in this specific example, the user file access device and location are consistent with the past behavior, with the logging records. There is no password change or account management anomaly were found. The AI is looking at the specific alerts, and there is 4 alerts of the same types in the past 7 days, aligning with known benign testing activity by IT departments. So there is no phishing related alerts or no unusual pattern were detected. So all those signals are strongly supporting the conclusion of no malicious activity. That's most likely a false positive. So as an analyst, I may have a different opinion. I may want to change that verdict. I may want to say that's a true positive. This is a suspicious event that need more investigation. So based on that feedback, the AI is going to learn and to recognize that there is additional context, additional check that need to be performed in order to come up with an actual verdict. So in this case, this alert is now determined as true positive, updated by the user, and that's again provides some feedback from the AI to, in this specific example, investigate further this specific event. So this is the autonomous SOC loop in practice. The AI analyze, reason, and explain what's matter. Analysts remain in control, validating decision, as we have seen, and shaping how the system learns. The outcome is faster triage, cleaner signal, and a security operation that improves with every interaction. So now let's see how it works in details with a deep dive, starting with detection management. So detection management is where an autonomous SOC truly begins. Every SOC faces the same challenges: too many detection, uneven quality, and blind spot created by vendor silos. So the quality of detection directly drives alerts volume, analyst workload, and ultimately how much we trust AI and automation. So when detection are noisy and opaque, autonomy breaks down. That's why a systematic, transparent approach of detection management is foundational to everything that follows. What we see here is the detection management page. We see every single detection that has been implemented in the product. There is a third-party integration. It's alerts coming from third-party vendors that we integrate and analyze and correlate. There is ML detection that has been developed by Stellar Cyber. It's all the ML machine learning models to detect behavior anomalies, as well as the rule-based detection. It's all the Sigma rules that has been implemented in the product in order to detect non-specific threats. So in this page, we see all the detection. Each of them have a state. They are either on, off, or silence. When you set a detection in silence mode, you don't see the alert, but you have a count, what we call the hit count, of how many times this alert would have been triggered if it was enabled. That's an easy way to understand the impact of enabling a detection without overwhelming the SOC. So let's look at a specific detection, account creation anomaly, for example. So what anomaly means in this specific situation is that this is not necessarily malicious, but that's different. Pay attention. That's a way to prioritize the signal, prioritize alerts on behavior that has been observed in the environment. So the possible data source tab lists all the different data sources that can feed that specific detection. Google Workspace, Office 365, Windows Server, Sensor, etc. And that little green checkmark indicates that, yes, there is events actually that has been received recently that contribute to that detection. That's a way to indicate which data source is actually contributing to that specific event, specific detection in my environment. Some detection may require some customization. For example, the impossible travel detection can be customized with specific minimum distance, for example, or speed of traveling to adapt to your specific needs on specific organization. So in this specific impossible travel anomaly, you can customize the minimum speed in miles. You can customize the speed of traveling, and you can adapt those parameters to your specific environment. So that's a way for the AI to understand what is the baseline in your environment and where to actually trigger an alert when there is an anomaly. As I mentioned earlier, Stellar Cyber is multi-tenant by design. That's applicable as well for detection management. You can create multiple profiles of detection. So all those configurations for every single detection that are on, off, or silence, and even the customization can be assigned to a profile, and that profile could be assigned to one or many tenants. For example, you could have a banking customer profile, you could have a retail customer profile, etc. And you can assign that profile to a specific tenant. For example, I can assign this tenant B and C to that specific customer banking customer profile, and those two tenants will share the same detection configuration profile. So that provides a consistent configuration for all those tenants that are sharing the same type of environment, and that helps to scale onboarding and to facilitate the fine-tuning on those detection management and detection configuration. Now that we have seen how Stellar Cyber produces high-quality detections, let's look at how we enrich and interpret that signal using our threat intelligence platform. Threat intelligence only creates value when it directly improves decisions. In this segment, we will show how Stellar Cyber operationalizes threat intelligence, ingesting it from multiple sources, and applying it automatically to alerts. The goal is simple: turn external intelligence into clear prioritization and faster response without adding noise or manual work. Let's see how it looks like. The threat intelligence feed. As you can see in this page, we list all the feeds that have been ingested in the product. Some are pre-built, that means they come up with the product, like ET-Pro, Abuse.ch, Fish Tank, OpenFish, DSH, Alien Vault, etc. Some are what we call premium. That means you, as an end user, you bring your own threat intelligence license, your own key, for example, like Anomaly, RedSense, SOC Radar, or even CrowdStrike, to ingest those IOC from those vendors into the platform. You can create your own custom feed using the taxi standard or the TSV format. That way you can ingest your own custom IOCs into the platform. Let's look at how those IOCs looks like in the platform. We are supporting 4 types of IOCs: domain name, IP address, URL, and file hash. Those IOC are coming up with metadata, like the confidence score, the risk score, the time that they have been created, the different data source that they are coming from, and some specific tags like CNC, command and control, emerging threats, abuse IPDB, etc. So all the information that you need to understand the context behind these specific IOCs. So now let's look at how those IOC are surfacing into the alert. We are going to go back to our case, the compromised credential, and look at that impossible travel anomaly alert. If we look at the detail of that alert, we have a TI enrichment, threat intelligence enrichment, and we see that we have a source IP reputation field that is being enriched with a tag from this IOC. So we know that this specific IP address that we were looking at is associated with the botnet and with this SOCO 404 campaign, which is a crypto mining campaign from early 2025. That context is helpful for the AI to understand, obviously, the level of threats, the level of risk associated with these specific alerts, as well as for the analyst to understand the broader context of that campaign on that specific attack. So now that we have seen how threat intelligence enrich detection on cases with global context, the next step is using that information to actively investigate and uncover hidden risk. Threat hunting today often turns into a query writing exercise instead of investigation. Analyst has to remember field name, syntax, schema, and time window, and one small mistake can mean no results. Stellar Cyber removed that frictions. Analysts simply ask questions in natural language, and the system translates that intent into the correct backend query and return results instantly. The focus shifts from how to search to what to investigate. For threat hunting, I'm going to use the AI investigator. I'm going to create a new notebook and ask a question. For example, is there any suspicious process execution? So the system is translating my question, is there any suspicious process execution, into the actual Lucene query. And I don't need to remember every single field that are associated with process execution. The system is returning alerts in this specific example, and as well as generating a summary of the events that has been returned. From now on, I can ask a follow-up question. For example, which host are impacted? So again, the AI is translating my question into the Lucene query, and the AI is remembering what was the context. So when I ask which hosts are impacted, the AI is remembering that the impact is related to suspicious process execution and will tailor that query to that specific context. The result is, in this case, a top 10 of the most impacted hosts in this environment. We can see this in the form of a table, as well as in the form of a bar chart or even a pie chart. So what we can see here is that we have this IP address 10.33.4.208 that is really standing out with 45 count of this suspicious process execution. Let's deep dive into that specific IP. So I'm going to copy the IP to clipboard, and I will ask, show me all alerts for IP that we copy and paste. So the AI investigator is translating my question into this specific Lucene query, focusing on that specific IP address, and returning the alert that has been observed for this specific IP. And we can see that there is multiple ESET protect alert, so indicating that there is some malicious activity happening on that specific endpoint. So now I can narrow down my investigation by asking a follow-up question. For example, show me all user logins associated with this IP. So again, the AI investigator is translating my question into the Lucene query with the right parameters, with the right syntax and the right argument that is required to surface the logging as a success or fail for that specific IP. And here we can see that we have one failed login. And if we search for the username field, and here we can see the user login associated with that specific device, Adrian. So this is an example of investigation, how you can use natural language to investigate alerts and pinpoint specific behavior that you are looking for in your data. So in addition to the AI investigator, Stellar Cyber provides a library of threat hunting queries. So the type that you see here in this view are predefined queries that will help to pinpoint your search to specific use case, specific data source, or specific environment that you are looking at. So if we are looking at Office 365, for example, so such a view helps you to narrow down your search and pinpoint some anomalies. Like, for example, here we have a spike of logging failure. That's from those users. That's maybe something that you may want to prioritize during your investigation. So the idea is that Stellar Cyber is doing the heavy lifting of all the different investigation that you may want to do and help you to streamline your search and investigation workflow. So once we identified and confirmed malicious activities through hunting, the next step is actions. And this is where automated response turn insight into immediate impact. So up to this point, we focus on detection, investigation, and confidence. Now we close the loop with response, where decisions turn into actions. The goal here isn't blind automation, it's controlled, repeatable response driven by analyst judgment. To see how Stellar Cyber help to automate response, we are going to go back to our case, compromise credential that we watched earlier. So as we have seen earlier, on the left side, we have the recommended action. So the AI is recommending specific steps to respond to the threats. On the right side, we have the way to actually execute those actions. Like block an IP, you can select the IP that is associated with this event. For example, the 57.129. We have the connector that is going to be used to execute that action. And in that case, if we want to block that IP, we know that this is an external IP, we want to block incoming traffic. And we want to do it for the next 5 days, for example. By submitting this action, you create a new policy in the FortiGate firewall to block that incoming IP address to reach the network. In addition to blocking the IP address, you may want to contain the host. For that, you will connect with the EDR CrowdStrike connector, for example, or you may want to simply run a script to execute some custom actions that are predefined in your environment. So those responses are manual, right? But once an analyst is confident in the response for this specific threat pattern, we don't want to repeat that manual response every time. So this is where automated threat hunting playbooks come in. We are simply capturing proven human decisions and turning them into specific policies. Let's see how it looks like. So to automate those responses, we are going to use what we call the automation playbooks. So from here, you can create your own automation playbook. You give a name to the playbook. You can specify the condition when this playbook is going to be executed. And more importantly, you can specify the type of action that are going to be executed. So this playbook will be executed in the background and continuously analyze new alerts. And once detection, investigation, and response are working together, the final question becomes, how do we measure impact, track outcome, and prove value? This is where dashboard and reportings come into play. So we will close with how all of this operational work turn into visibility and reporting. This is where day-to-day operation translate into measurable outcomes. So first, Stellar Cyber provide predefined dashboard that are focused on specific use case. We are going to look at a few examples here, like operational or ingestion source. So in this dashboard, we see the operational aspect of the ingestion. We can see what that type of data are flowing into the system, like the traffic, the different type of sources, including the different individual sensor that has been deployed, the different syslog source, Windows source, etc. And that's helped to spot potentially spike or gap into the ingestion process. You can customize such reports as needed using the edit capability, and you can customize this dashboard as needed. You can modify the widget or create a new one. Stellar Cyber also provide some very specific use case dashboard. For example, the ITDR, so the Identity Threats Detection and Response dashboard that helps to pinpoint specific ITDR alerts, such as external user logging, failure anomaly, or suspicious AWS activity, etc. So all those alerts that are related to identity are combined together into this dashboard, and that's, again, gives you an overview of what is happening and helps potentially to pinpoint some anomalies. Dashboard as well could be associated with the list of raw events that has been used to populate those charts, and that's what we see here with the list of different records that are analyzed to produce those pie charts here. In addition to those general reports, Stellar Cyber provides some specific compliance reports, such as PCI, CIS, or even HIPAA reports. So you can customize those reports as needed and use it for your regulatory compliance requirements. So dashboards are for running the SOC day-to-day. Reports are how you communicate value, risk, and result to your team. Reports are generated automatically from the same data, no rework, no export, no screenshot. They can be scheduled, time-bounded, and customized per tenant or customers. For MSSP, reports can be fully branded and delivered as a PDF to your customers. This is how you show not only just what happened, but how it was managed. So let's look at the case report, for example, that summarize the full life cycle of cases. So again, these reports can be customized with your own branding. It contains a table of content, some executive summary, some nice bar charts here, as well as some detail about the case, including the ingestion funnel, which is very useful to understand what are the different layers of filtering and managing on all your data. So from ingestion volume to the actual true positive. So that's a nice report that you can generate again automatically. You can schedule it to be generated on a daily basis or on a weekly basis and communicated as a PDF to your customers. So to summarize, dashboard run the SOC and reports prove the value. Together, they close the loop between detection, response, and measurable outcomes. So to wrap up, what you have seen today is the full autonomous SOC loop in actions. Detection that earns their verdict, AI that reasons and explains, and analysts that stay in control and shape the system over time. Stellar Cyber isn't just about amplifying human productivity. It creates entirely new productivity by executing work autonomously, continuously, and at machine scales. So security teams can focus on judgment, not repetitions. Thanks for watching. If you want to learn more, visit our website at stellarcyber.ai. We would love to continue the conversations.